Hey, this is Mrs. Hickman. So today I'm going to be going over the review that we went over today since I was out. So let's go ahead and get started. So the first part of it was fill out the unit circle, list degrees, radians, exact values of sine, cosine, and tangent. Okay, so I'm right here. Okay, go ahead and label your four corners. So you got 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, now put those in pi or radians. So to convert to radians, you multiply by pi over 180. So you got 0, pi over 2, pi, 3 pi over 2. I probably should not put that there. Or 2 pi. Okay, so now I'm going to go ahead and do my exact values of cosine, sine, and tangent. So remember how you do this. You do cosine is x, sine is y, tangent is the value outside the parentheses. So you got 0, and for 360 is going to be 1, 0, 0 divided by 1 is 0. This is 0, 1. 1 divided by 0 is undefined. And then you have -1, 0. 0 divided by -1 is 0. Down here you got 0, -1. -1 divided by 0 is undefined. Now we're going to do our middle. So this is 30. I'm just going to do 30 and then go on that. So, well, we'll do 30, 45, 60. Okay, I'm going to go ahead and fill out my exact values here. So how you remember these, so everything is over 2 except for tangent. Okay, so you start here for cosine and you do square root of 3, square root of 2, square root of 1. Which is 1, and then you go back the other way around. Okay, now we're going to do tangent. 1 divided by square root of 3 is going to be square root of 3 over 3, rationalizing the denominator. Square root of 2 over square root of 2 is 1. Square root of 3 over 1 is square root of 3. Okay, now I'm going to stick with 30s. So all the 30 angles are going to be pi over 6, something pi over 6. So, and they're all symmetric. So to find the angles in quadrant 2, that's going to be 180 minus quadrant 1 angles. So here's quadrant 1. Okay, theta prime. So 180 minus theta prime is 150. And it's going to be something pi over 6. It's going to be 150 divided by 30, which is going to be 5. Then here you're going to do 180 plus theta prime. So 180 plus 30 is going to be 210 degrees. Okay, so I'm going to be something pi over 6, which is going to be 210 divided by 30, which is 7. Then over here, this is going to be 360 minus theta prime, or quadrant 1 angle, and you're going to get 330. Okay, it's going to be something pi over 6. 330 divided by 30 is 11. Now exact values, you're just looking at the sign. The only difference is the sign is different. So x is negative over here, so that's square root of 3 over 2, 1/2, and tangent is negative. Okay, here in quadrant 3, x is negative, or cosine is negative, sine is negative, tangent is positive. So that's going to be square root of 3 over 2, negative square root of 3 over 2, negative 1/2, and square root of 3 over 3. Over here, cosine is positive, sine is negative, and tangent is negative. Okay, 60. Okay, 180 minus 60 is 120. Okay, all the 60s are going to be something pi over 3. This should be a little bit more symmetric. So all the 60s is going to be something pi over 3. Okay, do the same thing as 30. 120 divided by 60 is 2. Okay, 180 plus 60 is 240. It's going to be something pi over 3. So it's going to be 240 divided by 60, which is 4. This is going to be 360 minus 60 is 300. 300 divided by 60 is going to be 5 pi over 3. Exact values, we have 1/2 square root of 3 over 2 and square root of 3. The only thing that's different is the sign. So x is negative. So we have negative 1/2 square root of 3 over 3, negative square root of 3. Okay, x is negative, so is y. Oh, that's a 2, sorry, that's a 2. 2. Tangent's positive in that quadrant because you got negative square root of 3 over negative 1. And then you have a positive x, a negative y, and then a negative tangent. Now 45. 180 minus 45 is 135. 180, and then that's going to be something pi over 4, okay? Okay, I'll get back to the radians later for these. 180 plus 45 is 225 degrees. 360 minus 45 is 315 degrees. So 45 is pi over 4, so you're going to be doing 1, 3, 5, 7. So this is going to be 3 pi over 4. That's going to be 5 pi over 4. This is going to be 7 pi over 4. Okay, now do your exact values. You got negative square root of 2 over 2, square root of 2 over 2, negative 1, negative square root of 2 over 2, negative square root of 2 over 2, 1. And then for the 45, that's going to be square root of 2 over 2, negative square root of 2 over 2, and negative 1. There is your unit circle. Next is going to be how much time is required for an investment to double if interest is earned at a rate of 6.25% compounded monthly and continuously. Okay, so compounded monthly is going to be the formula A equals P times 1 plus R over N to the NT. Okay, so it's asking how much time is required for the investment to double. Okay, so the investment I'm going to say is P, and then we're doubling P. So that's going to turn into 2P equals P times 1 plus R, which is going to be, so the rate is 6.25%, so R is going to be 0.0625. Okay, N is number of times per year it's compounded. It said it's compounded monthly. There's 12 months in a year. And then we have 12 times T. So we're looking for T. Okay, so a little bit of algebra divided by P. Divided by P. You get 2 equals, I'm going to go and put that in my calculator. Okay. Okay, so you have 1 plus alpha y equals, makes the numerator of the denominator thing, 0.0625 over 12. That's 1.00520. Do not get rid of that, because do not round on these. Just keep it there. Hold tight. I'm just going to round it on my paper to 1.005 to the 12t. To get that exponent down, I have to natural log both sides. Okay, So I'm going to have natural log of 2 equals 12t ln of 1.005. So to find t, I'm going to divide by 12 and the natural log of 1.005 on both sides. Okay? Now, I'm not touching that, so this is what I got. So I'm going to have ln of 2. So I have ln of 2 over 12 ln of second negative sign. Okay? Do not round it to the end. And that is going to give you 11 years. So it's going to be 11.1 years. Okay? Part B. Compounded continuously. Compounded continuously is A equals PE to the RT. So we know A is 2P because it's doubling. The rate is 0.0625 times T. Divide by P on both sides. So you get 2 equals E to the 0.0625 T. Bring down the T, you get natural log of both sides. Natural log of E cancels out, so that just comes down. So you have the natural log of 2 equals 0.0625 T. Divide by that. Okay, and you get ln of 2 divided by 0.0625, 11.09, or 11. Here we'll round that to the 100, so this is 11.09 years. Okay, 3. A little blurry. There you go. 3. The accompanying figure shows the velocity v of t of a particle moving on a coordinate line. So the first thing we're going to do is find the intervals where the velocity of the particle is moving to the right, left, or still. So velocity is moving to the right when it's positive, it's moving to the left when it's negative, and it's still when it's crossing the t-axis, or most likely kind of staying there for more than a second. So it's going right from 0 to about 2. The only one you could be definite on is 0, because you can't have a negative t value. 0 to 2 seconds, union, and then it moves right here. 5, it's right the whole way up here. 5 to 11, or no, 5 to 12 seconds, because it's all positive. Okay, it's moving to the left where it's negative. So it's moving to the left 2 to 4. Union. Well, that's it. It's just 2 to 4. Still, so standing still, so it's changing direction here. So it's changing direction at t equals 2. If you want to write that, changing direction at, so it's changing direction at t equals 2. And it's staying still where it's kind of on a 0 slope. Okay, so it's staying still from 4 to 5 seconds. And 6 to 7 seconds. And 8 to 11 seconds. Okay. So that's moving right, left, still. Okay. So now we're going to be graphing the acceleration where it's defined. So pretty much everywhere it's defined. So you need to determine the slope. So kind of go in units. So you're going to do, let's do some work here. So here's for 3B. Okay, so I got 0.00, and then I have 1, 0.2. Okay, find slope is going to be 0.2 over 1, which is 0.2. So from 0 to 1, it's 0.2. Okay, it's just a straight line. It's just telling you what your slope is. Next, we're going to do from 1 to 3. So then we have points 1, 0.2, and then we have 3, negative 0.2. Slope is going to be negative 0.2 minus 0.2 over 2, which is negative 0.4 divided by 2, which is negative 0.2. So that's from 1 to 3. It's going to be negative 0.2. So 1 to 3. Okay, and you kind of bring the line down here to connect it. You're doing this each time you change the slope. So now we're going to go from 3 to 4. So we have 3, negative 0.2, and 4, 0. So 0 minus a negative 0.2 over 4 minus 3 is going to be 0.2. Okay, slope 0 here. That one's easy. That one shouldn't be going over so far. Okay, now over here, we're going to have 5, 0, and then 6.3. So we have 5, 0, and 6, 0.3. So 0.3 minus 0 over 6 minus 5 is going to be 0.3. So from 5 to 6, it's 0.3. Okay, this is a 0 slope, so it comes down here from 6 to 7. Okay, 7 to 8. So we have 7, 0.3, and 8, 0.2. So we have 0.2 minus 0.3 over 8 minus 7 is negative 0.1. 7 to 8 is 0.1. Okay, it's a constant line from here, so that's 0. Okay, and now one last one. We have 11, 0.2, and 12, 0. 0 minus a negative 0.2. Oh, hold on. 0 minus over 12 minus 1 is going to be negative 0.2. Okay, there's your acceleration graph. Okay, next. When is the particle speeding up or slowing down? So it's speeding up when velocity and acceleration are the same signs. It's slowing down when they're opposite signs. Okay, so we're going to just, so every time we change intervals, that's where it's going to go. You might want to start, it doesn't matter where you start. You could either do velocity first and then acceleration, or you can also use this 0 to 2 type thing. It's honestly up to you what you want to do. So we can do velocity. I'll do velocity first. Velocity. Well, let me start right here. Velocity. This is going to be acceleration. Anytime the slope changes, okay, you could look at velocity here, because if it's positive slope, then acceleration is going to be positive. Okay, so we got a positive slope from 0 to 1. So that's one interval we can look at. So we got 0 right here, and then we have 1. So 0 to 1, we have a positive slope, and velocity is above the t-axis, so it's positive. Okay? Now the slope's changing, but we cross this axis. So I'm going to go 1 to 2. Okay? Acceleration is negative, which you see here in the pink, or you can look at the slope. So negative acceleration from 2 to 3. So if you want to, you can write a 3 here. And velocity turns from a positive to a negative. 4, we have a positive acceleration, positive slope, negative velocity. Okay, and then it's 0 right here, so we don't really care about that. And then things start to change at 5. 5 to 6. 4 to 5. 4. I guess we can put that there. 4 to 5 is 0. 5. 5 to 6. Velocity is above the t-axis, and acceleration is positive. It's a positive slope, so acceleration is positive. Positive and positive. And then we got 6 to 7. Velocity is positive, but acceleration is 0 because it's a line. Then we have 7 to 8. So velocity is above the t-axis, but acceleration is going to be negative. You can also see it right there. It's negative there. Negative, positive, 7 to 8. Okay. And then it goes constant here from 8 to 10. Eight to 10 is going to be a positive, but acceleration is going to be 0. And then we have 10 to 12. Oops, 10 to 12. Or this is supposed to be 11, not 10. And then from 11 to 12, you have positive velocity, negative acceleration. Okay? So it's speeding up. So it's speeding up from 0 to 1. Union. 2 to 3. 5 to 6. And that's it, seconds. And it's slowing down from 1 to 2. Union. 3 to 4. Right here. Zeros don't count. 7 to 8. It's a union symbol. 7 to 8. And 11 to 12. Okay, there you go. Next one. A soccer ball is kicked into the air at t is greater than or equal to 0. So we're starting at time 0. Is given by the function s of t is negative 4.9 t squared plus 10t, where s is measured in meters and t is measured in seconds. Find instantaneous velocity and acceleration at any time t. Well, that's pretty easy. You just find the derivative of that. So we have a, for a, velocity. So we got s of t is negative 4.9 t squared plus 10t meters. This is the position function. Alright, and then so you got 2 times negative 4.9 is negative 9.8t plus 10 meters per second. A of t is the derivative of that, which is going to be negative 9.8 meters per second squared. Every time you do a derivative, you add a time. Okay, how high did the ball go? So before you figure out how high, you got to find out when. When is the ball at maximum height? So to find that, you set velocity equal to 0. So you got 0 equals negative 9.8 t plus 10. Algebra, minus 10, minus 10. Negative 10 equals negative 9.8 t. Divide by negative 9.8. And you get, I think 10 divided by 9.8 is 1.02 seconds. Okay, to determine how high, you put the seconds into the original equation. So you have s of 1.02 is going to be negative 4.9, 1.02 squared plus 10 to 1.02. Easy way. Woo! Sorry. I will fix it. Okay, you go there. You go there. Okay, so easy way to put this in. So there's my 1.02. You got negative 4.9. Second answer squared plus 10 second answer. Okay, so it reaches this maximum height at 5.10. Okay, so its maximum height is at 1.02 seconds, and then the height is going to be 5.1. Now we have how long is it aloft? Now, you can either multiply the time by 2, but I don't like that way. But algebraically, this is how you would do it. You would set 0. So you're done with the position function. 0 equals negative 4.9 t squared plus 10t. 0 equals t, negative 4.9 t plus 10. So you got t equals 0, negative 4.9 t plus 10 equals 0. Subtract 10 on both sides, divide by negative 4.9. Is 2.04. So t equals 2.04. So it's at the ground at 0 seconds and at 2.04 seconds. Okay, and that is that one. Other side. Alright, so we're going to be finding the equation of the tangent line of y equals x squared tangent x at x equals pi. Okay. So we have y equals x squared pi. Okay, first things first, you got to find the slope. So you got to do the product rule on how to get this. So you have f equals x squared, f prime equals 2x, g equals tangent x, g prime equals secant squared x. Y prime is going to be 2f f prime g, so 2x tangent x, plus g prime f, x squared secant squared x. Now to find the slope, you're going to be evaluating x at pi. So slope is going to be y prime of pi, which is going to be 2 pi tangent of pi plus pi squared secant squared of pi. So tangent of pi, if you remember from the unit circle, is 0. So 2 pi times 0 is just 0. Secant squared pi, if you don't know secant, you know cosine. So that's going to be pi squared times 1 over cosine squared of pi. Cosine of pi is -1. So pi squared times 1 over -1 is going to be negative pi squared. Okay, so there's your slope. Now you got to find your point. You will have your x value to the point, so to find the y value, you put the y value in there. So y of pi is pi squared tangent of pi. Well, we already know what that's going to be. It's going to be 0. So we have m equals negative pi squared, and then we have our point pi 0. Slope-intercept form, you get y equals m x minus pi plus 0, which is negative pi squared x plus pi squared. Okay, and there's your equation of the tangent line. Okay, next is find the derivative using the definition of the derivative and alternate definition of the derivative of the function to find the slope at a. Okay, so pretty much you're just going to put a where you see x right there. Okay, definition of a derivative. So this is 5. Yep, that was 5. This is 6. Definition of a derivative is limit as x or h approaches 0 of f of a plus h minus f of a over h. You can make it an x, whatever floats your boat. I don't care. Alrighty, so f of a plus h. So we got the limit as h approaches 0, f of a plus h. So a, okay, so a is 3, so we can honestly make this 1 over 3 minus 1. Okay? I think that's supposed to be an x. Okay, 1 over 3. So where you see x, you're going to put that. So that's going to be 3 plus h. I'm just going to wait till the end to put the 3 in. So it's going to be 1 over a plus h minus 1 minus f of a, which is going to be 1 over a minus 1 over h. If you want to, now you put 3 in. Equals a limit as h approaches 0 of 1 over 3 plus h minus 1 over 3 minus 1 over h You can wait till the end to put that in, or you put it in now. So then you have the limit as h approaches 0 of 1 over h plus 2 minus 1 over 2 over h. Least common multiple, you got 0 here, 0 there, denominator here, denominator there, denominator here is 1. Multiply everything by 2 times h plus 2, 2 times h plus 2, 2 times h plus 2. Okay, h plus 2 cancels out here, so you're left with the 2. Watch this minus 2 over 2. Those cancel out, h plus 2 over 2h, h plus 2, which is going to give you the limit as h approaches 0 of 2 minus h minus 2 over 2h, h plus 2 equals the limit as h approaches 0 of negative h over 2h, h plus 2. That helps us out a lot. That cancels out those h's. So then we have limit as h approaches 0 of negative 1 over 2 times h plus 2. Evaluate at h equals 0, which equals negative 1 over 2 times 0 plus 2, which is negative 1/4. Okay? Now we're going to do the alternate definition. So here's all that right there. Oops. Accidentally took a picture. Okay. Alright, next one. Alternate definition of the same problem. I wonder if I can turn it now. Oh, won't let me turn it. Okay, so we have the limit as x approaches a of f of x minus f of a over x minus a. Okay, so f of x minus f of a. So we got the limit as h approaches a is 3 of f of x, which is 1 over x minus 1, minus f of a, which is 1 over 3 minus 1, over x minus 3. So we have the limit as x approaches 3 of 1 over x minus 1 minus 1 over 2 over x minus 3. Okay? Least common multiple, x minus 1, x minus 2, 2, x minus 1, 2, x minus 1, 2, x minus 1. So you get the limit as x approaches a. So the x minus 1 cancels out, you're left with 2 minus x minus 1 over 2 times x minus 1, x minus 3. Oh, that's supposed to be a 3, my bad. Okay, so then we have the limit as x approaches 3 of 2 minus x plus 1 over 2 times x minus 1, x minus 3 equals the limit as x approaches 3 of negative x plus 3 to x minus 1, x minus 3. Okay, so our goal is to try to cancel this out. We're so close. So what I'm going to do is factor out a negative. Over 2x minus 1, x minus 3. So that gets rid of our x minus 3 problem. So then we have the limit as x approaches 3 of negative 1 over 2 times x minus 1, put in 3, Negative 1 over 2 times 3 minus 1. 2 is negative 1/4, which is what you got for the other one. Okay? Next question. Find dy over dx. So we're going to be finding the derivative of sine of 4x over 3x plus 1 squared. So this is a happy chain rule one. Maybe not for you, but for me, sure. Y equals sine of 4x over 3x plus 1 squared. Okay, quotient rule is probably the best way to go here. So you got f is sine of 4x. G is 3x plus 1 squared. Okay, so you gotta do the chain rule to get your derivatives here. U is 4x, u prime is 4, f of u is sine of u, f prime of u is cosine of u, f prime of x is going to be cosine of 4x, which means f prime is going to be 4 cosine of 4x. Okay, now over here, u is 3x plus 1, u prime is 3, f of u is u squared, f prime of u is 2u, f prime of x is 2 times 3x plus 1. So g prime is going to be 3 times 2, which is 6, 3x plus 1. Okay, now the derivative. Y prime, f prime of g, so 4. Usually you put the polynomials in front of the trig functions. 3x plus 1 squared cosine of 4x plus g prime of f. 6, 3x plus 1 sine of 4x. Okay? Now you have to do greatest common factors here. So right now we have 4 and 6. What's a common is 2. And then we have 3x plus 1. So you look for the smallest one, so that's a 1. Okay? So now you're going to divide each term by those. So you have 2, 3x plus 1. 4 divided by 2 is 2. 2 minus 1 is 1. Okay, and then the same thing over here. 6 divided by 2 is 3. 3x plus 1 cancels that, so you get the sine of 4x. Oh, I forgot about the, so all this is over g squared. All of this is over 3x plus 1 squared. Or to the 4th, because 2 times 2. So you got 3x plus 1 squared, so 2 times 2 is 4. Okay. So final answer, you got, well, not final answer, we'll see what happens. 2 times 2, 3x plus 1, cosine of 4x, plus 3 sine of 4x, over 3x plus 1 cubed. If you want to, you can distribute things through, like you could distribute this 2 back again, so you would have 4 and 6. And then 6. If you want to distribute through, that's fine. So if you wanted to have 12x plus 4 cosine of 4x plus 6 sine of 4x, that's fine. This is fine too. Okay, next we're going to be, well, let me give you a better picture of this. Okay. Next, we're going to be graphing. Graph the function x squared minus x. X is less than or equal to 1. So let's go and look at that. So we have x squared minus x. X is less than or equal to 1. So since this is an equal to, you're starting at 1. You're starting at 1. The equal to just means it's going to be the defined point. So f of 1 is going to be 1 squared minus 1, which is 0. So we have 1, 0. Okay. Now I'm going to go further to the left, so I'm going to pick 0. F of 0, hold on. 1 minus 1. I'm missing a middle point. I'm going to do 0.5 because I think it's right. 0 is going to also be 0 too. But this is a parabola. Well, oh, sorry, that should be. So I'm pretty sure it's going to go like that. Let's try f of 0.5. So that's going to be 0.5 squared minus 0.5, which is negative 0.25. So about here. If you want to do another one, you could do f of negative 1 is going to be negative 1 squared minus the negative 1. So that's going to be 1 plus 1, which is 2. Okay, just ignore that dot right there. That was a whoops. Okay, now we're going to do 3x minus 2 is greater than 1. So 3x minus 2 is x is greater than 1. F of 1 is going to be 3 times 1 minus 2, which is 1. So 1, 1. And if you want to, you could just do slope. 1, 2, 3 over 1. Okay, so let's answer some questions. What is f of 1? That's going to be the defined point, which is going to be 0. Okay, next question is find your left and right limit. So left is with a negative. So the limit as x approaches 1 from the left of f of x, so you go over here, is going to 0. Right? So the limit as x approaches from the right is going to be y equals 1. So remember, you're looking for y values here. The limit as f of x, the limit as x approaches 1 of f of x cannot exist because the left-hand limit has to equal the right-hand limit. Is the function continuous at 1? No. Okay, so for a function to be continuous, it has to be a defined point at 1, but the limit also has to exist. So the limit, so there is a defined point, but limit does not exist. Okay, number 9. Is find the derivative, find dy over dx when y equals x e to the x minus e to the 3x. Okay, product rule. f equals x, f prime equals 1, g equals e to the x, g prime equals e to the x. So f prime of g, so you're going to have y prime is e to the x plus x e to the x minus e to the 3x. Now remember, d over dx of e to the u is u prime e to the u. So u is 3x, derivative of 3x is 3. Okay, done. 10. Use log differentiation to find y prime. So you have y. So you have this right here. I'm going to go ahead and write rational exponents now. So that's going to be 2 t to the 1/2 over t to the 1/3 to the 5th. I'm going to go ahead and distribute. So 2 to the 5th, t to the 5/2, t to the 5/3. Okay? So, before we do any calculus, you need to use properties of logarithms. The first property I'm going to use is the quotient rule. So that's going to be, oh, first I got a natural log of both sides, still an I before I do anything. So you got natural log of y, natural log of this. Okay, quotient rule first. ln of y equals ln of 2 to the 5th t to the 5/2 minus ln of t to the 5/3. So ln of this minus ln of that. Next, the product rule. You have 2 to the 5th times that. So product rule is going to be ln of this plus ln of that. Next is the power rule. So if you see a power, you put it in front. So you have 5 ln of 2 plus 5/2 ln of t minus 5/3 ln of t. Okay? Now you are ready to do your differentiation. So ln, so the derivative d over dx of ln of u is u prime over u. Okay? Watch this. This is implicit, so every time you differentiate y, you have to add a y prime. So this is going to be, so the derivative of y is y prime times 1 over y equals, that's a constant, so that's 0. So ln of t, you're going to have 5/2 times u prime of t, which is 1 over t, minus ln of u is u prime, so 1 over u, which is 1 over t. Okay? So if you want to, you can go in and bring this y up here. So y prime equals y times 5 over 2t minus 5 over 3t. Lastly, all you're going to do is substitute what y was at the very beginning, which was 2 t over the cube root of t to the 5th times 5 over 2t minus 5 over 3t. That's all I need. You do not need to combine fractions there. That is fine. Okay, next we're going to be doing implicit differentiation. So we're going to be finding the derivative, finding dy over dx, which is finding the derivative of x squared y plus xy squared equals 25. So the product rule, so f is x squared, f prime is 2x. F is x squared, f prime is 2x. G is y, g prime is y prime. So 2xy plus x squared. For these, I like to keep y prime a different color. Now you get to do the product rule again. Plus, that was a negative, do a negative and do a parentheses there. Plus, f is x, f prime is 1, g is y squared, g prime is 2y times y prime. F prime of g, so y squared, plus 2xy times y prime. Equals, derivative of 25 is 0. Put everything that's not a y prime on the other side, so minus 2xy minus y squared. And then if you want to, you can go ahead and factor out that y squared. I'm just going to wait. Factor it out. Divide it. Y prime equals negative 2xy minus y squared over x squared, I think I messed up somewhere, x squared plus 2x. Oh, that's plus 2xy. Whoa, I almost forgot that one. 2xy, 2xy. Okay, and there's your derivative. 12. So given the function f of x equals x cubed plus 1/2 x squared minus 10x plus 2 over the interval negative 4 to 3. Okay, I'm asking you to find increasing and decreasing. So increasing, decreasing, and extrema is the first derivative, so let's find that. So f prime of x is 3x squared. 2 times 1/2 is just going to be x minus 10. Set it equal to 0. Okay, I'm going to do the cross method. A and C, so 3 times negative 10 is negative 30. B goes here, A goes here. So any factors of 30 that subtract get 1. That's going to be 6 minus 5. Okay? So you have 0 equals x plus 2. X minus 5 over 3. If you don't like it like that, just shoot that 3 right there. So x plus 2 equals 0. 3x minus 5 equals 0. Right now you're testing for critical points. So x equals negative 2 and x equals 5/3. So let's make sure both these are in the domain. So negative 2 is 5/3 is I'm pretty sure in the domain because it's like, yeah. Okay, so I need to determine increasing, decreasing, max or mins. So don't forget to check your endpoints here. So you got negative 4, 3, negative 2, 5/3. Intervals is going to be negative 4 to negative 2. Negative 2 to 5/3. 5/3 to 3. 1, 2, 3. Okay? Okay, now you're going to check. So you need a value between negative 4 and negative 2. I'm going to choose negative 3. put this into factors, it's going to be easier to see. Okay, so you got -3 plus 2. 3 times -3 minus 5 is going to be, so -3 plus 2 is a negative. 3 times -3 minus 9 is a negative, so that's a positive right there. Number between -2 and 5/3, I choose 0, which is going to be 0 plus 2. 0 minus 5, which is going to be a positive, times a negative, which is a negative. F prime of 2 is going to be 2 plus 2. 3 times 2 minus 5 is going to be a positive and a positive. Okay, so I determined increasing, so it's increasing from -4 to -2, union 5/3 to 3. It's decreasing from -2 to 5/3. Okay, extrema. So don't forget to check your endpoints. This is probably it's gonna be a max, okay? Because it's increasing. So this is increasing. So this is gonna be a min. Because see, it's increasing, decreasing. And then increasing. Okay, so you see that's going to be a min. I don't know if it's going to be an absolute or a local. That's either going to be a local max and or absolute max. Is going to be a local min or absolute min. Remember, local and absolute can be the same thing. And then I don't know whether that's going to be a local max or an absolute max or both. So let's see. So extrema. F of -4. So you put this back into the original equation. So you got -4 thirds plus 1/2 4 squared minus 10 times 4 plus 2. Easy approach to this. All I'm going to want to see in your exam is that you're plugging it in. That's it. Okay, so what you can do, you can go ahead and put this graph in. X of 3 plus 0.5x squared minus 10x plus 2 graph. Okay. Trace. So we hit trace and then put -4 in. It's -14. Okay. So we have -4, -14. Okay, if you want to check, you can also use the evaluating tool by going in here and doing -4 up 3 plus 0.5 -4 squared minus 10 times -4 plus 2 is -14. That's another way you could do it too. Okay, now we got to find another one. F of -2. -2 cubed plus 1/2 -2 squared minus 10 times -2 plus 2. Okay, just go into the graph, hit trace, hit -2, you get 16. That's a negative. F of 5/3 is 5/3 cubed plus 1/2 5/3 squared minus 10 times 5/3 plus 2. That's about -8.65. Okay. So see, there you go. And then f of 3. 3 cubed plus 1/2, 3 squared minus 10 times 3 plus 2 is 3.5. Okay, so let's do absolute first. So absolute max, you look for the highest point. So negative 14 is definitely not 16. So that's your absolute max is at negative 216. Absolute min is going to be the lowest point, which is going to be at negative 4, negative 14. Local max, okay, that's going to be, well, this is a max, so that can also be negative 216. Okay. That's a max, so at negative 2. No, negative 2 and 3. So that's a max here because it's going from the endpoint, so it's going to be a max on there. So 3.5. Local min. Okay, local min. You got negative 4, negative 14. And then we have 5/3. So that's min right here. 5/3. Negative 8.65. Okay. So that's how you find increasing, decreasing extrema. It's probably the hardest one. Next, concavity. So you find the second derivative. So f prime of x was 3x squared plus x minus 1. F double prime of x is 6x plus 1. Set it equal to 0. 6x plus 1. Subtract 1, divide by 6. You get x equals negative 1 over 6. So now we're going to see if this is going to be a point of inflection. Also, back to this. The signs have to change right here to be like a maximum or minimum, okay? These are endpoints, so you just look at the first derivative test in 5.3 to determine that, okay? Or you can look at your graph. Okay? All right. So don't forget your interval. You got negative 4, 3, negative 1 over 6. Okay? So choose a number less than that. I'm going to choose negative 1 because it's easier. So from negative 4 to negative 1 over 6, I'm going to choose f double prime of negative 1, which is going to give me negative 6 plus 1, which is a negative. Then I got negative 1, 6, 2, 3. F double prime 0 seems like the best way to go. 0 plus 1 is 1, which is positive. So it's going to be so this part's the concave down from negative 4 to negative 1 over 6. Concave up from negative 1 over 6 to 3. Point of inflection is going to be at negative 1 over 6. The original function of negative 1 over 6. Oopsie, calculator fell. Which is going to be 3.68. Okay. So if I were to draw this graph, you don't have to draw, I just want you to see it. So you have 1, 2, 3, 1, 2, 3, 4. Look at our points. Negative 4 was negative 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, got that. Negative 2, 16 I'm not going to make that up there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whatever. It's 16 up here. Negative 2, 16. 5/3. So that's like 1.66. Yeah, 1.66. 5/3 is negative 8.65. So 1, 2, 3, 4, 5, 6, 7, 8. And this is 1. Okay, so it's a max. And then 3, 3.5. Okay, and then it's changing concavity about here, 3.67. 1, 2, 3. Okay, so this is what your graph is going to look like. So you got, I'm not concerned about zeros, as you can tell. Okay, so that's where your absolute min is. That's where your absolute max is. Okay. Then you have local min, local max, local max. Okay, and that is your midterm review. Alrighty, I hope it helped. If you have any questions, please email me. Okay? Alright, bye-bye.